few games that I have. So as you can see from the demolished tower up here, Mega Jenga is one of them. So grade 7, just with how the calendar panned out and everything else, grade 7 math, like regular 7th grade math, we played Mega Jenga today to review for the Chapter 2 test. Now, in my honest opinion, I don't think it really benefited them all that much, but it helped them with engaging with each other in solving math problems, and for the potential, like, if there were going to be a team test, kind of encouraging that whole, like, everybody working together sort of thing. So, homework tonight, 4453, pick 6, and we'll flip screens. So, who found the slope of their stairs? All right, can you come draw us a picture explaining the slope of your stairs? Actually, blank paper is probably going to be easier for you. Can you come up and draw a picture? Yeah, like what you measured, how it was, and what the slope is because of what you measured. Like up over. Hey, attention should be up here, please.
This is 5.5 inches.
Really? That's smaller than what I anticipated.
Wait, no, this is 10. Never mind. The other one is 5.5. Okay, this is 10 inches. And then this is 5.5. And I divide it.
So how do we figure out the slope?
I just divided them.
That is how we figure out the slope. Anytime we want to talk about the slope as a decimal, all we need to do is the division of that delta y over the delta x, right? So her delta y, what's the rise in this situation? 5.5. Now, if any stairs have a higher rise than a run, they're going to be hard to climb. And that, like, so by ADA, which is the American with Disabilities Act, the ADA has set down certain laws of the steepness of stairs and things like that in public buildings. So, like, if I had a like hip surgery or something, and I go to a public building, I'm not climbing super high stairs, right? And also, certain buildings have to have ramps installed so that wheelchairs and things can get around. But if I do 5.5 divided by 10, I get 0.55 as the slope up. So it's about a slope of a half, right? So when we talk about how long the stairs have to be, like if you were building a house, if you need to go up 10 feet, because a normal house is like 10 feet per floor, if you count like the space in between the floors and stuff, ceilings are only like 8 or 9 feet tall. How long would the stairs have to be to go up 10 feet approximately? Any initial guess, gut reaction? If the slope is about a half, right? It's 0.55, she said. Here's the easy way. If I said we have to go up 10 like feet, is that rise or run? Rise, right? What should my bottom become, my denominator? 20. So this is what builders call stringers. Like, I don't exactly know why, but a stringer is the piece of wood that you cut the notches into to be able to build stairs. So they would have to figure out, okay, I'm going to run about 20 feet long, go up about 10 feet. How long does my stringer need to be? Longer than 20 feet. Because think about it, if you're going 20 feet long, and then you have to go up also, you need some extra length. That is what we call the hypotenuse of a right triangle. So we will get into more of that as we go. Yeah, thank you very much. So, as promised, pick these things. Because you're not a dum-dum. All right. So now we need to talk about some math, and I'm going to clean up this mess here in a minute. So in the last several lessons, we've been finding connections between different relationships of patterns. Yesterday we were talking about slope. But now we're going to go back and look at those tile pattern things that we've had been doing. So if you remember, the other day we looked at a pattern that started at a certain value, of tiles, right? And it changes a certain amount of tiles or squares or boxes, whatever you want to say, every time we take a step or we go a figure number. So we can describe these things in really 4 different ways, right? The table, just XY, like a T-chart. Graph, like we just kind of saw with the stairs, right? If I have an X and a Y coordinate axis, I can make the graph of my line. Pattern, just by actually like drawing it, showing it, like visually representing it. And then a rule, that kind of goes 2 ways. I kind of wish they had an equation here also. Rule could be verbal or it could be mathematical rule. So it could be start at 3, add 4 every time, or it could be y equals 3x or 4x plus 3. Right? So you could write it mathematically, you could write it verbally. So we have a couple different representations here. We want to check, is this right? Right? So we have A, B, C. We want to try to figure out, double check our objective. We want to try to figure out all 4 representations of these situations. So A gives you 2 of them, and we only have to do 2 more. So let's do A together. Then I'm going to have you guys do B and C and D on your own, like with your teams. So A gives me figure 3 in the representation, and then a graph. Based off what figure 3 shows and what the graph shows, can anyone make a rule for me? Because remember, our 4 things, and actually I should take a snapshot of this so it's up on the screen. Not clear. There has to be ink for me to be able to capture it. So, graph, we're good. Pattern, we're good. We're missing table and rule, right? So please, in your notes, set up a table and a rule. You don't have to copy down what they have, because if you are numbering correctly, and you put that this is number, what number is this? 42. It's still up on the TV, actually. You missed it. You could always go back and look in your book. So you don't have to draw what they have. You can if you want. Based off the graph. Sorry, now I'm talking slow because I'm looking for my cards. Based off the graph, Jesse, where do you think we start? Yeah, you can go fast. Savannah, what's our initial value? We're still working with whole numbers here, right? We'll eventually be doing partials, but right now we're just doing wholes. More or less than 3. According to our graph. Like, ignore this for a minute. According to our graph. Make a guess. What do you think? No pass? I mean, or you can just make it. I mean, this is a safe place. You can make a guess. No? Braylon? Guys, you're killing me. Lizzie? Mallory? I quit. We're done. Help me out. What?
I think X is 0 and Y is 4.
Y is 4. We actually did this either yesterday or 2 days ago. Remember when we drew an awkward thing and then we drew 3 more off to the right, 3 more off to the right, 3 more off to the right? Like we said, that was one way we could do it. If this is figure 3, these got added during figure 1, those got added during figure 2, those got added during figure 3, because we see right here, my growth or my slope is 3, right? 3 up for every 1 over. Now this graph is not drawn to scale. That's why this looks longer than that. So don't trust what it looks like. Trust the math that you know. But yeah, exactly right there at the start is 4. So we make this table. We have an X of 0, a Y of 4. Connor? It is. If we start at 4, that's our B. If we grow by 3, that's our m. So then I could fill in some spots on the table. 1, 7, 2, 10, 3, 13, 4, 16, and that's probably enough. Please make sure you have those down in your notes, and then with your group, start investigating B, C, and D. So, you are figuring out how to represent this. B only gives you one of them, in the other 3 ways. Now, pattern, where you actually draw it out, that's probably the hardest because there's a lot of options of how it can look. But you want to make sure that you can represent this with a table and with a rule, like the y equals type rule. So for our table in B, we know a couple x, y's, right? When x is 4, what's y? When x is 7, what's y? 58. So what I know is a certain delta y for a certain delta x. From there, I could figure out the slope. I'm going to let you guys investigate that on your own for a few minutes. If you get B done, move on to C. Same thing, then move on to D. I'm going to give you probably at least 5 minutes to talk about these things, try to figure them out, draw them out on your paper, whatever works for you. So dive in. By the way, in case I haven't told this class, I have a heart thing. So if you ever see me taking this pill, it's, so my heart doesn't explode. It's not really that simple, but it kind of is. If you're curious, document lunch. It's kind of interesting. And I've seen my heart in 3 dimensions, and that was sweet. To see your heart working, the flaps, like. Seriously, that's how your heart sounds. Your heart, when you go on I forget what it's called. The things where they like put them on like your mom's stomach when they're pregnant and they can see the baby inside. They do that with your heart, and then you can listen to it. And seriously, your heart sounds like because it's like shooting stuff through, and it's opening and closing into you. It's crazy. It's a little bit like of a wetter sound than that. It's more like. It's hard to make. I could log into OSU and show you guys pictures of my heart if you really want.
Yeah.
No time right now. And I don't even remember my login info. I don't log in very often, only if I have a bill.
So helpful. No, it makes sense. No, I
Wait, are you on B or C?
I'm on B right now, and
So wait, where'd you get 2?
I'm trying to figure out what offended. So 4 to 7 is 31. This 8.
Right.
58 minus 31 is 27.
Okay.
That's
That's the delta y. Then the delta x is this from 4 to 7. Delta y is 27. I don't know where you came up with 2. This is 3, right?
Yeah. I was looking at the line.
We can determine our slope by any delta y over the corresponding delta x. Right? So we know our delta y here, and we know our delta x here. Even though our delta x isn't 1, we can still determine our slope. It depends on the figure whether or not it can have a negative. Does that make sense? Like, because you'll run out of tiles eventually, and then you would show it as like missing tiles, or if you make them like red or something like that. If you make them red, they would represent like negative tiles. All right, let's make sure we're all on the same page with B. So delta y is 27. Delta x is 3, making my slope 9, which means it should work out if I add 1, I add 9, I add 1, I add 9, I add 1, it works. But now we can go backwards, right? Subtract 1, subtract 9. Subtract 1, subtract 9. I'm good, yeah? Double checking my addition. Subtract 1, subtract 9. Subtract 1, subtract 9. Which makes our rule what? Connor? Questions on this? If we were to actually draw a figure 0, it is the lack of 5 squares, or it is negative 5 tiles, or it's really hard to conceptualize, but it starts negative. Which really what that means is if I extend this line, where it crosses the y-axis will be at that negative point. Now, there isn't necessarily a realistic representation of this, right? Not necessarily. But maybe I got a job mowing the grass for Mrs. Schneider. She's my neighbor 2 doors down. And Mrs. Schneider, I'm going to give her a deal so I get paid $9 every time I mow the grass. But I broke her trash can last week, and I owe her $5 already. So I start my job owing her $5. But as soon as I mow the grass once, and this is actually at a positive value, right, I then have $4 of profit that I made. Right, I paid her back the 5, and now I have 4. Then every time I mow, I gain $9 more. Right? We can make a real situation that would make sense with it. You just have to decide, what do I use the negative as? Negatives are nice to use as like owing money or like in debt to something. No, I did not. I like Mrs. Schneider a lot. She walks her dog around her neighborhood, and her dog is very cute. And then my dogs always bark at them, and I have to wave and say I'm sorry because my dogs are huge and her dog is tiny. See, we have a table for up to figure 3, and then we have figure 8. We're going to use the same skills that we did on the last one. Delta x, delta y. So I'm going to make sure I give you guys more time, and then if you're done with that one, do D. What is all this? No, it's Labiba. At least a little bit of it is. I can remove. This must have fallen out of her folder. I thought it was one of you guys was just like taking up my floor. I'm like, what the heck is going on?
No, we don't do that. We're good.
We don't do that here. Mrs. Goldring's over there telling people Discovery Days are next week. Only trust Mrs. Goldring so much. If what she says seems wrong, it is not next week. It's the week after. Yeah. Yep, I'm not going to let you guys be confused. What? Can anyone walk me through finding the slope and everything in C? Is that a hand or no? I can't know. George?
Yeah. Okay, so if you have the T graph, you do 3 minus 8, and that would equal negative, right?
I mean, up to you.
Yeah,
Sure.
right.
I mean, so that's our X, so you're saying.
Yeah, so it'd be 3 minus, so negative 5, and then 12 minus 2 is 10, and then that would equal negative 2, or 2 over 1. And that would equal your M, and then you would do, and then you would go from, if you want to find everything in between 8, you would do plus 4. I mean, you do plus 2 every one. You have to.
So we need to go back and find our initial value, right?
Yeah.
This is kind of like the most important thing if I'm going to write a y equals.
Yes.
Because I already know the slope. Y equals 2x, but then I need plus something. So moving forward each step, like if I move forward to 4, I add 2, you said.
Yeah.
Sorry, I take away 2,
Yeah.
so I get to 10. If I move backwards, what do I do to my 12? Add, okay, so that's 13, that's 16. Oh, I start at 18 tiles, or whatever, and take 2 away every time. So maybe this is I have $18 in my backpack, and every time I go tutoring at the library, I purchase a drink for $2. How many weeks will I go before I run out of money? Or I mean, whatever. I just thought of that 'cause last night I was tutoring, and the kid I tutored had like scratchy throat, went and bought a drink. Make up a situation that works for you. We start at whatever 0 time, 0 moment with 18 of something. And then we lose 2 every time we move forward. Maybe I have 18 discs in my disc golf bag, and every time I go disc golfing, I end up losing 2 of them in the river. Would be a problem that would make sense there. Thinking about that because we're trying to make a disc golf course behind Phoenix. Like, make it relative to you. So then, check it. Here's how you easily make a graph. Sorry, Mrs. Cullen. We start at 18. Right, at 0, at x is 0, we start at 18. Don't put any other numbers on there. When will x, after how many weeks, let's say I'm doing the disc golf one, how long does it take me to lose all my discs? 9 weeks, right? And then just connect those. That's your graph. Now, that's as simple of a graph as you are able to make, but that's an accurate graph of our situation. It's not. Did you say snazzy? I don't. That's really simple. I don't think I call it snazzy. Questions? We're trying to today make sure you really understand this stuff. I'm debating if we're going to take a small mastery on this tomorrow. So I don't like surprising you guys. We might have a, put down the puppy dog eyes. Like, we take masteries to make sure that we're good or to adjust and correct ourselves. We don't want to go too far with any mistakes that we might be making, because I know you guys don't really like check your homework for accuracy. You just like do it, which is fine. Like, that's what we're going for right now. Later in the year, I'll post answers, and like you guys should probably check if you want to get the most benefit. We might have like a 3 or 4 question mastery tomorrow, just on like finding slope, finding the other representations. Like if I were to try to predict the future, because I guess I'm in charge, we'll likely have a mastery involving this sort of stuff. Like small, but like a couple questions. There will probably be a couple different situations, but you'll have to do like the 4 representations for each of them. So I will likely make up problems that are like me disc golfing or my dog's food or something like that. Like I start with a 55-pound bag of dog food. Every day my dogs eat that, like How long until I run out of dog food? That sort of stuff. Yeah.
Can you get a test back?
That's also my plan with tomorrow. Because they're not in math. So if I didn't explain this to everyone, I'm holding off putting your grades in math because it confuses your parents and it confuses a lot of you. Because it will immediately show up in your revision box. But that is not what would keep you here because I'm putting that on quarter 2. So I just wait until you guys bring your Discovery Day forms back. Because normally when you're talking with your parents about your forms, they like want to see your math and everything. So I'm going to put those in math this weekend. So I'll give you your chapter 2 test back tomorrow. And then they'll go in math. And you will have to explain to your parents if they ask you, this is not quarter 1. I might need to revise this, but it's quarter 2. It does not impact Discovery Day. George?
Okay, so when you go home and ask about this, how can you
Distinguish?
Yeah, words are hard today. How can you distinguish which is from quarter 1 and quarter 2? Can you tell?
It says. So when you go on math, the assignment will tell you what quarter it's
Oh,
from.
okay.
Yeah, you click on the assignment and go to the detail. Yeah, Q1 or Q2.
Okay,
Q means
cool.
quarter. System.
Two things. Will the small mastery test tomorrow go towards this Discovery Day?
Oh, heck no. We passed grade cutoff. Monday was grade cutoff. Mr. Kabila is evil and he decided to squeeze in one more test. I'm joking. I should have probably put your chapter 2 on quarter 1, but I want all of you guys to be gone because we've never had that happen before. So if you guys could all get mastered, that'd be the first time in Phoenix history.
Phoenix history.
From what I've not been here the whole time, but like what I've been told and what I've experienced while I've been here is we've never had every 7th grader gone. I don't know. I haven't checked this recently. Then, sorry, second question.
Are you gonna get all that homework back at some point?
Yeah, but it doesn't really matter to you. Like, so that's the. I want to give it back to you guys when I give you hanging folders in the filing cabinet. Okay, so true story. If you guys want to know why I'm a little bit behind on grading and everything else, Mr. Smith and I, about a week and a half or 2 weeks ago, decided that we were going to try to write up a proposal to get a grant for a disc golf course to be installed, well, for us to install a disc golf course out behind Phoenix. So what we're looking at is what's called a project-based learning unit, and you guys would be involved in this. Like, you would be driving this whole thing. So we would analyze existing disc golf courses. We would analyze, like, we'd have you guys go out and throw discs and see how far you're able to throw your discs, and then we're going to design, if this grant gets approved, a disc golf course that will go on the Phoenix property and or potentially Perry Park over next door. So I've been putting a lot of effort into this. I was up till 11 o'clock last night cleaning up like my grant write-up and everything, because you have to do a bunch of different paragraph like responses. This is why I'm behind. So if I'm just straightforward, honest with you guys, I'm behind on stuff for you because I've been working on this. This got submitted today, so now I can catch up on everything else.
So is that like all your stuff that you needed to get done like now?
Yes, yeah, all the budgeting, all the everything else. So like if you're curious about this, I am requesting $5,278.12. But that's every single thing that we could need, including lumber for the pits that you throw from, gravel for the pits that you throw from, like everything. And discs. There's like $700 in here to buy discs for you guys. So, like, but we'll see if it happens. They just need it down to the penny. You have to have accurate budgeting. So, yeah. Yeah.
When will you like start building?
Oh, we will know by November 19th if we get grant or not. And then we'll start the unit. And then we wouldn't know until spring.
Oh, okay.
Yeah. Connor. I can't hear Connor, guys. Yeah. Oh, I'm sure there will be 8th graders. What? They would probably be jealous. So yeah, they might. Because now they were really close last year. Last year we had a Discovery Day, I think, where there were like 6 people that had to be here, and then another like 2 or 3 that were here working on a project. Like they were doing the project here at Phoenix. But yeah, they'd probably just be jealous. But I had checked 8th graders' map counts. I guarantee some of them will be here. Guarantee. There's no way that they're getting all their assignments taken care of. They're just not doing what they need to do. Well, certain 8th graders. A lot of them are awesome. A lot of the 8th grade class is rock stars. Some of them just don't like to work. And then D. So, hold up. Even if we don't look at the graph, and here's the question. Here's how you know if you're ready for the mastery. If I just gave you this, can you make the statement of this pattern starts with insert and goes, like, changes by insert?
Yes.
Meaning that at certain figure or whatever, or certain x value, I can find the y value, but like, as long as you can make those statements, you're good for any mini mastery that I throw at you tomorrow. So where do I start at here? 7. How do I change here? When I'm not using cart, a lot of times it just shout out the answer. I know you're getting frustrated because you want to be called on. So Braylon, because you keep wanting to be called on, fine, Tude. Do you want to be called on or not? Could you make me up a situation that this could be describing? That's one of the hardest parts of doing this. What could start at 7 and go down by 3 every time the x goes forward? It's okay if you can't. I just figured I'd give you the opportunity to answer. What if I say Magic Mountain? Could that help your thought process at all? Can anyone make me up a situation for this problem? Quinn?
I'm carrying a bunch of soda cans because my parents told me to go out in the garage and get a bunch of soda cans.
Okay.
As I'm walking, like, I take like a step, I drop 3 cans. Take another step, I drop another 3 cans. And then I take another step, and I drop the last one.
So you take like a third of a step, right? And you like drop. Yeah, so it's weird, right? Especially because it doesn't end up perfect down here. This is rather awkward. George, what would you say?
Okay, I would say, hi. First, you have $7 in your bank account. You have a credit card, and you're like, oh, credit cards are cool because I have unlimited money now, but you don't. So first, you get a pack of pencils for $3. Then you get a pack of erasers for $3. Then you get a Starbucks coffee that is for $6, but they reduced it for $3 because this is my story.
But do you have enough money for that Starbucks coffee?
But then you're in debt.
Yeah, now we're in debt. So I like George's situation, but you need to say debit card.
Debit card.
So credit, you don't put money on a credit card. You just. So I want to make sure you understand this. And these are banking terms.
I know, but on a credit card, you don't put money on there, but you have like money to spend.
No. So let me explain this. You're kind of right. But let me help you out. When you let me clarify this with debit card first. And you guys can start your homework if you want. That's really our lesson. A debit card, and you could go get a debit card right now. Your parents would have to be part of your account. You put a certain amount of money on there, and then you use that money. A credit card, if your parents are on the account, they can give you the card. Like you could have a debit card if your parents are the name on the account, and you could have your name on the card. Depends on the bank, but it could be your card, but it's their account. Does that make sense? Like debit cards, you type in a PIN, you type in a number, like a password. So a credit card, George, let me explain this. A credit card, and this is what's absurd. I went to get a credit card while I was in college. They looked at my financial information. They're like, okay, we'll give you a $7,000 limit. Now that was credit card number 2. My first credit card, they started me with a $1,000 limit. What that means is you don't have any money in the card, but I can spend up to $1,000 going into debt, effectively into debt, but then you pay it back. So you never put money on a credit card, you just pay it off. You pay back your debt. Yeah, if you don't control your spending. Yeah. So to clarify, this is homework time and/or AMA, ask me anything. So we have 7 minutes to kill. Yes. That's a credit card. Yep. Yes. Simon. You could use a different credit. So actually, not Simon. Sorry, I'm looking at Simon because now your hand's up. Connor's pointing out a fault that America has created in the financial system. I could use a different credit card to pay off my credit card, and then I just move where my debt is at. But the problem is, every month that your debt sits in your account, you accrue what's called interest, which means I buy a bike for $100, but I don't pay it off this month. Now I owe $115. I don't pay it off that month either. Now I owe $130. I don't pay it off that month either. Now I owe $145. Like, it keeps getting more and more. You should just save money and pay it. So, sorry, Simon, question?
I know I know this scenario for it.
Yeah? For this?
Yeah.
What do you got?
Every time I do a problem, like a problem that has to do with, like, a story math problem,
Yeah?
I slowly lose my sanity.
Huh. So, are you going to relate it to these numbers?
Yes.
Okay, so your sanity starts at,
7.
are we saying this is a scale of 10? It's a 0 to 10 scale, you're at 7 to start? Okay.
And then every
So, I asked you a word problem,
yeah.
right?
My sanity moves down by 3. I don't think Simon has any sanity left.
So, this is Simon slowly going crazy, right? So, he is solving the problem, solving the problem, solving the problem. Now his sanity is only at 4, or like a 40%, right? Solving the problem, solving the problem, solving the problem. Now his sanity is at 1, and he's like yanking his hair out, which there's a lot of. And then he's solving a problem, and now he's running around the park without any clothes on, and we have to figure out. Simon has gone insane. Simon, don't run around the park with no clothes on. That's a bad idea.
Yeah.
Savannah,
I know that we did for
question.
4th and 9 in the book.
Is it the last lesson?
Yeah, I was writing stuff down and then you like went through the problem really quickly and I can't remember what it was.
Sorry, yeah, it's worth going back to.
Mr. Hudson.
Yes.
My cousin, when we went to my cousin's house, my cousin, he said that like he said that his brother owed him like $20 or something on the video game.
Yeah.
And then he didn't pay him back that much, so he's like $50 again.
Oh, when we travel, when we go on our trip, if you don't bring enough money on your trip, I'll loan you money. I take plenty of money, but you're gonna owe me interest. So when we were in Chicago, we were up on the CN Tower, Willis Tower. It's really the Sears Tower, but now it's called the Willis Tower. And a student didn't have enough money. He wanted to buy a Lego Willis Tower. And I was like, dude, this is not a need. You're not gonna die without this. It's not food. It's not water. If you want to borrow money from me, I will hand you a $20 bill. It was like $15 or something. Said, I don't want the change. You are borrowing $20 from me. Every day is 50 cents interest. And he's like, okay, I'll take that deal. So between then and the rest of the trip, and like us getting back there, I think he accrued like $2 in interest. So then he went home, got $22 from his parent. Like, I was teaching him about math. Now I think when he brought it to me, I was like, okay, put this $2 in like some donation thing. Like I wanted it to be like, you can't just have money for free, right? Like if you borrow money from somebody, it's not just free. So Savannah asked about this problem from last night's homework. We're gonna do this again because it's a tough one.
I just like adding like stuff and then ended up with numbers.
So whenever we see something, anything, number, symbol, whatever, right up against the parentheses, it means it applies to the whole thing. So this means the opposite of x and the opposite of -1. So if I just copy this down, -2x doesn't change, -5 doesn't change, and I can make that plus a -5 if I wanted to. 2 minus 4x minus x plus 1. Are you okay with that? Then, like terms. Put your like terms together. 2 and 1 can come together and be 3. -4x, -x, -5x. Then we use inverse operations. And my suggestion was look for the most negative x. So my most negative x is -5x. To get that to become 0, we add 5x because they are inverses of each other. this equals 0 if we care to think about it. But once you get like skilled at this, you don't even really need to like write that or like you just know. This becomes 3x minus 5 equals 3. Then to get rid of that minus 5 or negative 5, we can add 5. And we get 3x becomes 8. Right? Because my 3 plus my 5. Yeah. Then this is weird because the inverse, not really weird, but the inverse of multiplying by 3, what's the inverse of multiplication? Division. So we divide by 3 and get that x is 8/3, or 2 2/3, or 2.6 repeating. Does that make sense? You don't need to have this mastered right now, but it's starting to get you comfortable with doing it. Yeah. We're out of time, guys. Sorry, George, if you need me to talk with me later. But I got more students coming in, so I got to get you guys out of here. Have a wonderful day, peeps. Yo, Discovery Day forms due tomorrow. Just another reminder. It's worth it.
I just had a question about
About what?